Here's a new type of problem. In this problem, we're going to balance this reaction in a basic solution, okay? Now, MnO4 minus is permanganate, all right? And permanganate is the purple solution we saw earlier. MnO4 2 minus is called manganate, all right? It's not as common, but that's manganate. Another thing, HO2 minus 1, that's a peroxide. Peroxides are very reactive compounds with an oxygen-oxygen bond. You don't see a lot of those most of the time. A hydrogen peroxide, which you can buy in the store, is a peroxide. They're very reactive. So anyway, in this problem, we have permanganate and the peroxide reacting to make manganate and also some oxygen. But this is going to be in base. First thing to do in these kind of problems as well is break the two parts into two half reactions. And again, you don't have to know necessarily which one is being oxidized and which one is being reduced. So it would be totally fine at this point to just have MnO4 minus going to MnO4 2 minus because they kind of look the same, okay? And you could also have the peroxide going to oxygen because they kind of look the same, and that would be totally fine. If you want to do a better job, then the peroxide has an oxygen with a -1 charge, all right? If you go back to the oxidation numbers, peroxides were an exception to the oxidation rules. So peroxides are -1. So that peroxide thing has a -1 charge, and it's going to O2, which is an element which has 0. So oxidation is going to occur. The peroxide is going to lose an electron to become like an oxygen atom. The other one, same kind of thing. Those are regular oxygens. We saw earlier that manganese is a +7 in the permanganate. In the manganate, all right, manganese is still the unknown. You've got 4 -2 oxygens, all equaling -2 this time. That's a manganese +6. So +7 to +6 can only happen if manganese gets an electron. It's gaining an electron to become less positive. But again, if you don't know oxidize and reduce, just put the parts that are similar together. The electrons, as we're going to see, will come out here in a little bit. This next step is kind of interesting. It's how to balance a half reaction for mass in a base. I'm going to show you the quickest way to do it first, but I'm also going to warn you that this way that I'm going to show you at first doesn't work very well for me. I a lot of times have problems doing these types of things the way that I'm going to show you. Some people are really good at it, and that's why I want to show it to you. I'm hoping that you're one of the people that can do it really fast. I'm going to show you in a little bit what I'm going to call Michael's method for balancing basic redox reactions. And my way works every time, and I totally nailed it. But it's a little bit longer. I'm going to warn you, okay? So if you don't like my step 2, just hang tight. And after this example, I'll show you the quote-unquote Michael's method, which does work, but it takes a little bit longer. Anyway, just like in acid, you can only add water and H+. In base, you can only add hydroxide and water, okay? Now, for the reduction side, we don't have to add anything because both sides have an Mn and both sides have 4 oxygens. But for the other one, you can see it's HO2 minus and O2. Well, the O2 doesn't have any hydrogen. When you're balancing in base and you're using hydroxide and water, you want to add water to the hydrogen deficient side. So the product side there has no hydrogen. We need to add water. But usually if you add water, then you usually need to add hydroxide to the oxygen deficient side. So you can see that by adding water, we now have 3 oxygens on the right, and there's only 2 on the left. Let's add a hydroxide to the reactant side. And if you figure this out, this reaction is looking at least balanced now for mass. Now here's the thing. You add water to the hydrogen deficient side, and you add hydroxide to the oxygen deficient side. That sometimes works for me, and if it does, it's a lot easier. But when it doesn't work, hang tight. I've got another method I'm going to show you. It's longer, but for me, it works every time. I'm going to call it Michael's method, and anyway, blah, blah, blah. Okay, so I'm assuming that this is good to go. You can at least see now that everything is balanced for mass. Step 3, we need to balance the reactions for charge. We can only add negative electrons. So for the first one, the oxidized part, both OH- and the peroxide have a -1 charge, and the O2 and the water have no charge. So that means I need to add 2 negative electrons to the product side. You can now see there's -2 on the left and -2 on the right. This is a way to confirm that this is an oxidation. The electrons, if they're products, that is the oxidation step. So if you didn't know that the peroxide going to oxygen was an oxidation, don't fear. If you've done it right, then this one, the electrons would come out as products, and that shows it's an oxidation. The reduction one, we're going to add 1 electron to the reactant side. That makes an overall -2 on the reactant side from the electron and the permanganate. And on the right side with the manganate, you have then -2. So -2 both sides, they're balanced for charge. The next step, we're going to balance the reaction so that when we add them together, no electrons show. We have 2 electrons in the first one, that's fine. The second reaction, we need to multiply by 2. Again, you don't want to have electrons show in your overall reaction. But now that we have that, you can see when we add them together, 2 electrons as reactants and 2 electrons as products, they cancel out beautifully. You'll be left with hydroxide plus the peroxide plus 2 permanganates makes oxygen plus water plus 2 permanganates. So when you cancel out the electrons, you can see you have a hydroxide, the peroxide, and the 2 permanganates, making oxygen plus water plus 2 manganates. And again, the idea here is that you add water to the hydrogen deficient side. H2O has more hydrogen per oxygen than hydroxide. You add hydroxide to the oxygen deficient side. You have a better oxygen to hydrogen ratio in hydroxide than you do for water. Now, if this method works for you, that's awesome. But on the other hand, if it doesn't work, hang tight. I'm going to show you Michael's method. The alternate basic balancing method, which I'm going to arrogantly call Michael's method, which is not really mine. I saw from somewhere, someplace. But anyway, what you want to do in this alternate method is you're going to use acid first and then neutralize with base. Now, here's my thing. I was always really good about balancing redox reactions in acid. But when it came to balancing in base with hydroxide and water, I always seemed to get myself tripped up. Like I can't figure out if hydroxide goes in the left or the right or the waters and stuff like that, and it's a real mess. So in this alternate method, what you do is you first write the balanced reaction as if it was done in acid. So you'll have H plus and water, but no hydroxide. Then at the end, you go back and you neutralize the acid with hydroxide. So if you had, for example, 2 H pluses on the reactant side, you would add 2 hydroxides to both the reactant and the product side. All right, you can't add to just one side. You have to add to both of them. 2 OHs and 2 H pluses would make 2 waters. That's the neutralizing part. There won't be any H plus left over. But then the opposite side, you'd still end up with 2 extra hydroxides, which were needed to balance everything out. So let's look at an example. Let's go back to the example we looked at. This is again permanganate plus the peroxide, making manganate plus oxygen. We're going to write the 2 half reactions, and the peroxide oxygen as well as the permanganate going to manganate. No big deal. This is the part that's going to be different. In the balancing for mass, instead of doing hydroxide and water, I would use at this point H plus and water. All right. And this is obviously a lot easier. Now, the second reaction with permanganate doesn't need anything. But in the oxidizing part, at first we had I think it was hydroxide on the one side and then water on the other, and it's really confusing. Well, with acid, it's easy. All right. The oxidized part there, you'd already have 2 oxygens on each side. An extra H is on the left, so we'd add an H plus to the right, to the product side. And if this was an acid reaction, this would be the right thing to do. It's not really, but temporarily it will work until we get to the end when we neutralize things. So this is the balanced half reaction not even balanced, it's mass balanced reaction in acid, and we'll look to see what happens after this. Next thing, balance each half reaction for charge. We saw that the one needs 2 electrons, and that hasn't changed. The other one, on the other hand, needs 1 electron, and that's totally fine. These parts won't change. It's only the balancing with H plus and water parts that will change. And then like before, we'll multiply the second reaction by 2. So I'm going to skip through these kind of fast. So we have 2 electrons and 2 permanganates, making 2 regular manganates. And then the last step then is to combine them. And like we saw earlier, 2 electrons cancel on both the product and the reactant side. So overall, this reaction balanced for mass and charge in acid would be like this. All right. It'd be 1 peroxide and 2 permanganates making oxygen, an H plus, and 2 manganates. And if this reaction was balanced in pHs less than 7, which would be acidic, score. However, this reaction is not a pH less than 7 condition. This is a basic condition. So the extra step now of this alternate basic balancing method, which I call Michael's method, is that we need to get rid of the H plus. So what we're going to do in the next page, we're going to add a hydroxide to both sides. In math, you can't add something to just one side. You have to add it to both sides, and we're going to do that too. And we're going to do that because H plus OH minus has a pretty large K. You can think about it as 1 over KW, very product favored. Anyway, H plus OH minus will combine to make water. So at the end here, we're not going to have any more H plus at all. We're going to have water now on the product side, and also we're going to end up with an extra hydroxide on the reactant side. So when you get to this step, what you need to do is get rid of the H plus. You need to add a hydroxide to balance each H plus, and they'll make water. But if for every hydroxide you add to the, say, the reactant side, you need to add 1 to the product side. It's the same thing for both sides. So for this reaction, what I would do, I'd have the peroxide plus 2 permanganates plus hydroxide. And on the product side, I'd have O2 plus H plus OH minus plus 2 manganates. And you can see that we added a hydroxide to both sides. Now, the parts in the square there are going to combine, and they're going to end up making, you guessed it, water. All right? So at the end of the day, if these two combine to make water, you're going to have the peroxide plus 2 permanganates plus our hydroxide, which we can't forget about, making oxygen plus a water plus 2 manganates. It's the same answer as we got before. It is a little bit more work, all right, because you do it in acid and then you go back and balance it in base. But I don't find that a hard thing to overcome. You can still check yourself, make sure that everything is balanced for mass and charge, that kind of stuff. Pretty cool. So you pick whichever method you want. If you can do hydroxide and water directly, it's definitely easier. And I still do that once in a while. If the problem is like good with me, then I'll just use hydroxide and water. But the minute I start getting confused, I jump over and I use this version where I balance first in acid and then neutralize at the end in the base. It's a pretty cool thing. The redox reactions handout, we'll talk more about that, so you might want to check that out if you're curious. So when you're balancing redox reactions, all right, pay attention to the pH of the reaction. If the pH is less than 7, it's acidic, so you'll use H plus and water. If the pH, though, is greater than 7, it's basic, so you'll want to use hydroxide and water to balance it. You never want to add things like O2 or oxygen atoms or just oxides or H2 or hydrogen atoms. I've seen these kind of things. People try and use them, but it's not that crazy. Again, at pH is less than 7, you can only add H plus in water. pH is greater than 7, you can only end up with hydroxides in water. You can always double check yourself at the end. You can double check yourself for mass and or charges, whatever you're uncertain with, and that's totally fine. So I highly recommend that you check your work at the end, make sure you're good to go. But I think after a little bit of work, you're going to knock these out and it won't be a problem. Cool.